We'll proceed in vector and commercial calculus. Vector and commercial calculus, this is the long discussion that we are pursuing. Commercial calculus or energy calculus or energy calculus. So how vector is kind of useful in energy calculation, and we have done tons of energy calculation while calculating the energy through force field of a energy source. If someone has energy source, if there is energy source, then certainly there is a force field there, and because of the force field any item is making movement, then energy source is losing energy, and that's how work is done by the energy source. Okay, if this is the energy source, because of the energy source there is a force field, and under this force field any item is moving from one location to another location, then force vector into displacement vector is the energy that net this energy source is losing. That is the that is the work done by the energy source, that is also called line integral, that we have seen. What we have seen there? Force vector dot displacement vector is the energy. Everyone knows that. Force vector dot displacement vector is the energy. But if force vector is an algebraic vector and displacement vector is an algebraic vector, in that sense, force vector dot displacement vector cannot be the energy. X into x is x square if it is algebra. But if one x is dependent upon another x, like one is y and one is x, one is y and one is x. Y is dependent upon x in a sense that y is function over x, and that function is again x. So y into x is x into x. If one is independent and one is dependent and it is algebra, then x into x is not x square. It is x square by 2. This is called integral calculus. If both are independent, to x into x is x square, it means both are independent to each other. There is more towards it. So better algebra is calculus. Algebra is a kind of, it is a special case of calculus. This is what someone can say. Similarly, better algebra is vector. Better algebra is vector. Algebra which has a direction is vector. A numerical science which has a direction is a vector. Okay, and algebra which has dependent and independent component kind of terminology, then it is calculus. Okay, now we have done force vector dot displacement vector is work done, energy calculation. If displacement vector, if displacement vector, if displacement vector is algebraic vector and force vector is algebraic vector, then force vector dot displacement vector, we call it force vector dot d of position vector. D of position vector. D of position vector gives the displacement vector rather than multiplying it directly. We come to calculus. Now, in that sense, we are into flux calculation. If there is a fluid, if there is a fluid that is passing through a surface, then how much is the volume of the fluid that is crossing the surface? If the surface has area A and fluid has velocity v, then v into A is the net flux. Or if this fluid is in some other direction, then how much it is coming out of the surface? Fluid velocity vector, fluid velocity vector dot product with the area vector. Area vector is perpendicular to the surface. If this is the surface, then area vector is perpendicular to the surface. Velocity vector is along the velocity of the fluid. Velocity vector dot product with the area vector is the velocity vector dot product with the area vector is the net flux. If velocity vector and area vector is perpendicular to the area, if they are along the same line, it is same as velocity into area. Otherwise, velocity vector dot product with the area vector. If area vector is algebraic and velocity vector is algebraic, then direct multiplication will not work. Velocity vector dot d of area position vector, d of area position vector is the net flux. Okay, so I believe we have covered it. Okay, we have covered it. Now, kind of, if I talk about the kind of a shape, I have a ball. I don't know how long it will work. Okay, so there is a full-fledged ball. This is exact sphere. This is exact sphere. Now there is an electric charge. I believe third time I'm giving this example. If there is an electric charge that is kept at the center of this ball, and because of the electric charge, electric current, electric field is generated all around it, and electric field is coming out of this surface. How much electric field is coming out of this surface? Consider electric field is a fluid. How much fluid is coming out of the surface? What is your velocity equation of the fluid? Then it is q into r vector divided by r to the power 3 dot d of area position vector dot d of area position vector or dot area vector. Now, since the electric field is generated at the center and it is coming as radial, okay, and surface area, everywhere you take surface area vector, it will be perpendicular to the surface area. So if this is the surface area from center, if you draw a line, this is radius and this is perpendicular to the surface area also. So surface area vector at any moment, it is in same direction with the electric field coming from the center. So we can directly multiply velocity vector dot area vector. Area vector, velocity vector, direct we can multiply because everywhere they are in same direction. Now it is q into r vector divided by r to the power 3. Area vector is 4 pi r square. 4 pi r square r unit vector. Or I can say the electric field is q into r unit vector by r square. Q into r unit vector by r square into dot product is angle is theta. So theta is 0. Now into 4 pi r square r unit vector. R unit vector gone. So q by r square into 4 pi r square. 4 pi q is the net flux, net volume q, meter q per second. That much is the electric field that is coming out of this surface. Mind blowing, amazing. Now, what we have learned is, now here we did directly velocity vector dot area vector. Otherwise, velocity vector dot d of position, area position vector or d of p vector. We on top of it write one arrow mark velocity vector dot d, that is differential d, and position vector p on top of it make an arrow mark p vector. V vector dot d of p vector integration over the xy plane. If this ball is centered at the origin, if I see if this is xy plane, if this is xy plane and ball is not kept on xy plane, xy plane is piercing the ball at the center. If this is the center of the xy plane, if this is origin on the xy plane, the center of this ball coincide with the origin. So half of the sphere is above the xy plane and half of the sphere is below the xy plane. Now in that sense, if we are calculating like this, then the net flux that is coming out is velocity vector d of position vector integrated along the area it is making on the xy plane. If you see that it is a circle. If I pierce xy plane at the middle, it intersection on xy plane will be circle. Integration over xy plane. Now d of position vector can be written as d of position vector by dxy plane into dxy plane. D of position vector by dxy plane can be written as dp by dx cross dp by dy dx dy. This is what we have seen till now. So net flux calculation is velocity vector dot product in a big bracket dp by dx cross dp by dy. It will come as a vector dxy plane dx dy. Settle it down, integrate over a region on xy plane that shape is making, and then you get so nicely the flux that is coming out of that surface. Okay, why every time you talk about a sphere, you don't have any other example? I have. Okay, so we will try kind of another example. Now kind of a I have a kind of a flat line. Okay, so I have a kind of a flat surface. Okay, if this is the flat surface, then consider this is x axis. Consider this is x axis. This is y axis. This is x axis. This is y axis. This is z axis. Now this is origin. Now this flat surface is kept on the x axis little bit tilted like this. Make sense? This is x axis. This is y axis. This is z axis. On x axis it is kept like little bit tilted like this. Okay. Now this point end point is 1 comma 0 comma 0. This is 0 comma 0 comma 0. If it is straight, if it is straight, then height is 3. So this is 3 comma, this is 0 comma 0 comma 3, and this is 0, this is 0, this is 1 comma 0 comma 3, this is 1 comma 0 comma 0, this is 0 comma 0 comma 3. Now this is little bit tilted toward y-axis like this. Now this is x-axis, this is y-axis. I rotated it, and this is z-axis. Now this is tilted little toward y-axis. If that is the case, then if I draw a line like this on y-axis, then that intersection is 1. Means a flat surface is on x-axis, and the height of the flat surface is 3. Along the z-axis it is 3, whereas along the y-axis it is tilted 1. So this point is 1 comma 1 comma 3, and this point is 0 comma 0. Okay, this point is 0 comma 1 comma 3. This point is 0 comma 0 comma 0. This point is 1 comma 0 comma 0. This point is 1 comma 1 comma 3. This point is 0 comma 1 comma 3. So along y-axis it is tilted 1. Along z-axis it is raised 3. Along x-axis it goes up to 1. Okay, this is the surface. If this is the surface, this is x-axis, this is y-axis, this is z-axis. This is the surface. Now there is a fluid that is passing like this everywhere, and equation of the fluid is zk. If this is xy plane, then here the fluid velocity is 0. But as we go along z, the fluid velocity is growing zk. If z is 3, there the velocity of fluid is 3. Z is 0 on the xy plane, the fluid velocity is 0 out there, zk. Now compute the flux, net volume of the liquid that is coming out of the surface. This surface is oriented upward this way. The surface vector is like this. If this is the surface, this is x-axis, this is y-axis, this is z-axis, and surface vector is along minus y. Okay, surface vector, if I consider this as how we consider surface vector? Orientation of the surface. If this is the edge of the surface, then how edge is oriented? If edge is oriented like this is anti-clockwise, this is clockwise. Make a right hand. Okay, if something is going, okay, right hand. If something is going clockwise, then this is the direction of normal. If something hop, it is like this. Okay, if something is going this way, whatever it is, if something is going like this, then this is the direction of the normal. Okay, if something is going other way, this is clockwise, I believe. This from my side, this is clockwise. If this is anti-clockwise, anti-clockwise means from X to Y. I believe left hand also works in this fashion. If this is X-axis and this is Y-axis, then this is Z-axis. Or right hand is like this. Okay. If it is rotating like this, it is anti-clockwise. Then the surface normal is like this. If it is rotating clockwise, the surface normal is like this, whatever it is. If now earlier this is this is x-axis, this is y-axis, this is z-axis. Now it is tilted toward y-axis and it is raised in along z-axis. Now I am moving the coordinate system. Now it is like this, where this is y-axis, this is x-axis, and this is z-axis. Now, if that is the case, then there is a fluid that is passing like this all around, and the fluid is ZK. Now, this surface is outward oriented like this. Now, calculate how much is the fluid that is coming out of the surface volume per second. That is the flux meter cube per second. Now velocity of the fluid is zk. At the xy plane there is no fluid at all. If you come up, velocity of the fluid is growing as you go up zk, and that is the surface. Surface is confined one point of the surface. Here it is origin. Here it is 1 comma 0 comma 0. This point is 1 comma 1 comma 3, and this point is 0 comma 1 comma 3. Find out the flux. Make sense? The flux is okay. I'll find out. I know the formula. I can find out. Okay, don't underestimate me. Now it is the flux calculation is the flux calculation is velocity vector dot area vector. What is area vector of this plane? I don't know. But certainly it will be algebraic kind of thing. If it is algebraic kind of thing, then velocity vector dot d of position vector, or velocity vector dot dp by dx cross dp by dy dx dy. Okay, what is dp by dx? If position vector is xi plus yj plus zk, then dp by dx is I plus dz by dxk. What is dp by dy? J plus dz by dy k. If you do cross product, it becomes minus dz by dxi minus dz by dyj plus k minus dz by dxi minus dz by dyj plus k. That is dp by dx cross dp by dy dx dy. Here velocity vector. Velocity vector is zk dot product with minus dz by dxi, oh, gone, k dot product I gone, minus dz by dy j, that is also gone, plus k, that remains. But anyway, you cannot run away. Anyone would say. Now you find the surface equation. Okay, so surface equation is minus dz by dxi minus dz by dyj plus k. That is the surface area vector. Okay, and that then dx dy. What is your surface area vector? Tell me clearly. Velocity, the net flux is velocity vector dot surface area vector. Surface area vector we can find through d of surface area position vector. D of surface area position vector is nothing but dp by dx, dp by dxy plane into dxy plane. That is dp by dxy plane into xy plane. dp by dxy plane is dp by dx cross dp by dy. This is what we have seen into dxy plane. dp by dx cross dp by dy is minus dz by dxi minus dz by dyj plus k dx dy. net area vector is minus dx dy dz by dxi minus dx dy dz by dyj plus dx dyk. This is the new area vector. Very nice. Now, can you calculate the flux? Flux is velocity vector dot product with minus dx dy dz by dxi minus dx dy dz by dyj plus dx dyk. Dx dy I can take it as a common factor. Now velocity vector dot product in a bracket minus dz by dxi minus dz by dyj plus k and then dx dy. Very nice, very true. What is dz by dx? Tell me. Dz by dx you are talking, right? So if this is the curve, if this is x-axis, this is the surface. Now dz by dx, if I make one unit of change along x-axis, how much z is changing? Now one unit of change if I make along x-axis, then z is not changing. Up. Okay, this is 0 comma 0 comma 0. This is 1 comma 0 comma 0. X change 0 to 1, whereas z did not change. Dz by dx is 0. Okay, what about dz by dy? Tell me. This is this is 0 comma 0 comma 0. This is 1 comma 0 comma 0. Means along this line y is 0. Let's see here. This is 0 comma 1 comma 3. This is 1 comma 1 comma 3. So if y is changing, now if I rotate this like if you see like this, if y is changing 1, then z is changing 3. Up. Okay. Along this line, along the x-axis, y is 0. If I make it fall like this along new x-axis, y is 3. It is y is 1. It is making one interception on y-axis. If this flat surface is growing 1 unit along y-axis, it is growing 3 unit along z-axis. If someone can see it. If I see from the y-axis perspective, now this is y-axis. This is y-axis, and what you see, this is x-axis. Now, if that is the case, then if x is growing like this from here to here, then there is no z movement. Z is 0. So dz by dx is 0. If this is y-axis, this is x-axis, and plane is like this. This is y-axis. If it happens like this, then if I move along x-axis, z is also moving. Then dz by dx is there. So minus dz by dx, I vector is gone, 0. Nothing is there. Minus dz by dy. If one unit of change is happening in y, z is changing 3. dz by dy is 3. So the surface equation is minus 3y minus 3j plus k. That is the surface area vector. That is a billion dollar research. What is the surface area vector of this? This is the surface area vector of this. That surface area vector, this vector, what we see the straight line, it is minus 3j plus k. Okay, tell me the direction only. I am not looking for the full. Minus 3j plus k divided by 3 square plus 1 square root 10. That is the unit vector along this direction. This is x-axis, this is y-axis, this is z-axis. Minus 3j plus k divided by square root of 10 is the surface area vector. If that is the case, then it is more toward the y-axis. There is no x-axis involved. This surface area vector is completely in yz plane. This is xz plane. This is yz plane. This is xy plane. In that sense, if this is the normal vector, this vector is completely in yz plane. Okay, and that's why it is minus 3j plus k divided by square root of 10 is the unit vector of this vector. I believe it's all right. Okay, if that is the case, then we are trying to find zk dot product with minus 3j plus k dx dy, where x is integrated from 0 to 1, y is integrated from 0 to 1. This is very famous example. This is not my research. Okay, if but the explanation is not, this explanation is not available anywhere else. Don't mind supporting us. Plus 91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. Plus 91 is the India country. Okay, in that sense, zk dot product with minus 3j plus k dx dy. J is gone because there is no j here. Zk k z z dx dy. Why you are falsifying now? How I can integrate z with dx dy? Z. Now let's go back and see that z and y relationship. Dz by dy equal to 3. Z equal to 3y. It is a flat surface, so everywhere it is same. It is not algebraic more or less. So z equal to 3y. dz by dy equal to 3. Z equal to 3y. Now it is, now earlier integration was z dx dy. Z dx dy. Now it is 3y dx dy. 3y dy dx. 3 I can keep outside, and y is y integration is y square by 2. Integration from 0 to 1, that is the y. That becomes 1 by 2. I believe it's all right. 1 by 2. 3 into 1 by 2, 1.5 dx. Integration of dx is x, 0 to 1. Gone. 1. 1.5 is the flux that is coming out of the surface. 1.5 meter cube per second is the, if water is flowing like this or any liquid is flowing like this, which has equation zk, as you go up in the z, the velocity of the liquid is growing, zk. In that sense, if that is the surface, then 1.5 meter cube per second of the liquid that is that is oozing out from the surface. Can someone believe it? So nice. Means calculus, you are amazing, you are awesome. You can do whatever you want. Vector calculus is the actual energy calculus. So now you can see how much is the volume per second the water is coming out. I believe it's all right. Okay, we will go with the another example. Now there is an electric current. This is a wire. See, not this is a wood. Consider this is a wire. This is a copper wire. This is a copper wire, and electric is flowing through it, and its magnitude is I. Then, if you see kind of some Maxwell law, I don't remember. Okay, then the Sir Max, whatever, Sir Maxwell or whoever is, has invented it, sir, because these are priceless. There is no price for this kind of invention. Anyway, now if this is the current that is flowing through a wire, then it will create a electromagnetic field around it like a circle, around it, everywhere around it. What is the equation of this electric current? That is, that is, I believe I by 2c, some constant. I is the current. Consider current is constant divided by some constant c. C is the velocity of electricity. That is same as electromagnetic radiation. That is 3 into, I believe 3 into 10 to the power 8 or something like that. 3 lakhs kilometer per hour. I mean 3 lakhs means 300,000 kilometer per hour. Whatever it is. I by c, some constant. Leave it. Now it is minus x minus yi plus xj divided by x square plus y square. That is the equation of the electromagnetic field that is around it. Now consider this is a liquid that is flowing like this, electromagnetic current around it. Now there is a sphere. There is a sphere. Up. I'll take bigger sphere. I don't know that is kept for some time. Okay, so there is a sphere. There is a this is not a sphere. Consider this is a sphere, and electricity is flowing from the center of it. If I pierce it in the center of it, or in the center of it, if I pierce it, then around it electromagnetic field is there. What is the flux? What is the flux that is coming out of the surface? Now, electric field is booming. That is a sound I believe when I pass near any transformer, humming sound will be there. Now, if there is a current, then electric field will be like this all around it. Okay, if you go more distance from it, the electromagnetic field, the power will decrease as per the square of r square. Okay, some constant minus yi plus xj divided by x square plus y square. X square plus y square can be considered as the radial distance, r square. If you go more radial distance from this line, the power will decrease as a square. So at distance 1, power is 1, then at distance power is 1 by 100. That much it will decrease. Numerator is minus yi plus xj, that is circular. Now someone can come. Many times I have explained minus yi plus xj. That will be circular in xy plane. This is z axis, this is x axis, this is y axis, this is z axis. Now along z axis, it is rotating like this. Now near to this electric line, it will be powerful. Slowly, this electromagnetic radiation will be weaker if you go along it. Now, if there is a sphere of radius A, and it is inside it, this electric current is flowing. Okay, then through the surface, how much the electromagnetic field will come out? That is the question. Okay, now minus yi plus xj, I cannot denote in r vector. This, if this is centered at the origin, the radius vector, there are three vectors in spherical coordinate system. One is theta, one is radius, one is phi. All along it, everywhere it is radial vector. Okay, but I cannot demonstrate the minus yi plus xj by x square. By x square plus y square, I can say r square. But minus yi plus xj, I cannot denote in radian. It is like it, something like in theta plane, it is rotated. Now, theta plane, radius plane, whatever. Now you calculate the flux. Don't shout. Okay, we are not running away. So we will calculate the flux. Now, flux is velocity vector dot product with the dp by dx cross dp by dy, dx dy of the sphere. Now it is minus dz by dx minus dz by dy minus dz by dxi minus dz by dyj plus k. This is the generic terminology in Cartesian coordinate system. Now velocity vector is minus yi plus xj divided by x square plus y square dot product with minus dz by dxi minus dz by dyj plus k. K is gone. Now it is minus yi dz by dx plus x dz by dy dx dy. Now for the sphere, z is the square root of x square plus y square plus z square equal to a square. Then z equal to square root of a square minus x square minus y square. Z equal to square root of a square minus x square minus y square. Dz by dx is minus x by a square minus x square minus y square. Dz by dy is minus y by square root of a square minus x square minus y square. If that is the case, then net dot product is minus yi plus xj divided by x square plus y square dot product with minus dz by dxi minus dz by dyj. K is gone. If you settle it down, it becomes minus y by x square plus y square into dz by dx into minus dz by dx minus minus plus. Now y into dz by dx, that is minus x. So minus yx divided by x square plus y square into square root of a square minus x square minus y square. Now next terminology is x into dzx by x square plus y square into minus dz by dy. Okay, minus dz by dy. Now minus dz by dy is minus y divided by x square plus square root of a square minus x square minus y square. In that case it becomes minus, no, I'm sorry, minus y and minus dz by dy. It becomes plus. So it becomes x into y divided by x square plus y square into square root of a square minus x square minus y square. Full becomes minus y into x divided by x square plus y square into square root of a square minus x square into x y divided by x square plus y square square root of a square minus, it becomes 0. 0. 0 dx dy. No flux is coming out of it. Okay, how it is possible? Now, your electromagnetic, if this is the electric current, electromagnetic field, everywhere it is making rotation like this. If it is making rotation like this, now if this is the sphere, now cut the sphere in slices. This explanation is not anywhere else. Now, this is the sphere, cut the sphere in slices. Everywhere one circle will come out. If you go more in height, then the topmost circle will have radius 0. Then radius will keep growing, and when it is centered at the origin, at the xy plane, the maximum radius, that is the radius of the sphere, will come. If you come down, then a smaller circle will come. You can cut in as many pieces you want. If you cut in 10 pieces, then 10 circle will come out. Okay, top 0 circle I am not taking. 10 circle will come out with increasing radius and then decreasing radius. Now, if that is the case, if you take 10 circle like this, and then here the electromagnetic field is circular everywhere, then the direction of the, if you take any circle like this, then the line, the curve direction, at that moment area direction is outside the center. So area direction is radial, whereas at that moment this circular direction is tangent to the circle. It is moving like this, then it is tangent to the circle. They make 90-degree everywhere. So the velocity vector and area vector is 90-degree everywhere. The angle between velocity vector and area vector, if you see the circle, it is 90-degree everywhere. So dot product cos theta is 0. But this will not work. You have to prove the way I proved. Otherwise, you say, my sentiments is saying that since it is rotating circular, the electromagnetic field is rotating circular, and the area also I am taking circular, they are in same direction. So area vector is perpendicular to the velocity vector, it is 0. This will not work in examination. So this is how it is. So it will be 0. Anyway, Mind supporting us +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country.